Uh, Greetings, ladies and gentlemen. Molweni. Okay, let's continue with our solve for x, grade 11 and grade 12, solve for x. Now, we're dealing with a fraction and radical signs or square roots. Okay, what to do when you're having this type of a problem? What you can do, in fact, always when we're having a radical sign, make sure that you put one of the terms on the other side, or you separate the terms. If they are more than two, you separate them. Then what do? You square both sides, because we know to remove a radical sign we have to square um, both sides of the equation to get rid of the radical sign, the square root. Okay, let's make an example. Let's say we have root x equals to 2. We're solving for x. Okay, this is an example. To solve for x here, we know that we have to square both sides to get rid of this radical sign, both sides. Then we have x equals to 4. Someone will ask him or herself, why does the radical sign and that 2 cancel? Like when we square, why does it just go away? Okay, that is one of the laws of exponents. We know that this, okay, let me write it again, equals to 2. This can be written as exponentially, can be written as x to the half equals to 2. To cancel this half, we know that we have to square, because the laws of exponent, raising a power to a power, multiply the powers. You know, when we multiply this by this, we're having 1. So exponent x to the 1, that's what we want. Then what is done on one side of the equation is also done on the other side. Therefore, x equals to 4. You see? Now let's continue. Now we're having this problem. We have to transpose the one term to the other side of the equation. So we'll be having x plus 4 all under the square root equals to 4 all over x minus 2. We square on both sides. Then the square root cancel with the 2 there. Then we have x plus 4 equals to, then 4 to the power. When it's a fraction and it's all to the power, so this affects both the numerator and denominator. So this is 4 squared, that is 16, over this is x minus 2. Now we're having this, we got rid of the radical sign, the square root. So we know that this has that invisible one below there, the denominator. Then you cross multiply this, multiply by this, x plus 4, x minus 2, this by that equals to 16. Then we can't solve, because yes, it is a quadratic, in quadratic form, factorized quadratic form, but this is not 0. Therefore, we have to first simplify, then after use quadratic form or factorization to solve the problem. So this becomes x squared, because x by x squared, x by negative 2 minus 2x, 4 by x, positive 4x, positive 4 by negative 2, negative 8, equals to 16. Now adding and subtracting like terms, this and this gives us positive x. We transpose 16 to the other side, we have negative 8 already. We'll be having negative 24. Are we together? Then now I think the shortest way is by factorization than using the quadratic form, because remember, you're gonna go to the calculator and put those numbers there. So here we'll be having x into x. Then what are the factors? The factors is that gives us 2, should be 6 and 4. 6 and 4, when we multiply them, they are giving you 24. This one should be positive to give us positive 2. Then this one must be negative, because remember this is negative, equals to 0. Then we have our two solutions. X minus 4 equals to 0, or x plus 6 equals to 0. Therefore, x equals to 4, or x equals to negative 6. Now, I want you to put this in mind. Whenever you were dealing with a quadratic equation that had a fraction or a radical sign, like square roots in the equation, you must take your solutions and put them back in the equation, plug them there, and see if the equation balances or is true. You see? So sometimes it's not always true that both of these solutions are at the roots of this equation, meaning they solve the equation. So it is very important to take them back to the equation, plug them there, and see if the equation balances. For example, here, if we take 4, okay, let's take a simplified equation of this. It should be this one, right? Must be getting 16. So if we put 4 here, it will be 4 plus, we're using this solution, the 4 plus 4, 6, 4 plus 4, 8, multiply by 4 minus 2, that is 16. Can we see that it balances? Now let's take negative 6. Negative 6 plus 4, let's take this one. Negative 6 plus 4, that is negative 2, into negative 6 minus 2, that is negative 8. So we're having negative 2 into negative 8. What is that? Is 16, right? It gives us 16. So in this case, both of them are giving us the correct answer. But if you take this 16 and put them in the original equation, you can see that this whole thing is not valid. It's what is it? It giving us a non-real number, like complex number. Those who are like have gone to the advanced mathematics, it will give us negative 8 here. We can't take a root of a negative number for you now, you see. So you can conclude that therefore x is not equals to negative 6, but x equals to 4. Now this shows you that you understand everything here. Not all the solutions are the roots of the equation. I hope it makes sense.